Hello, everyone. Good morning, good afternoon, good evening. Thank you so much for joining us here for our second CCNA Cybersecurity Prep session. My name is Rigo Villa. I'm one of the community managers on the Cisco Learning Network, and I'll be your host today. Before we dive into all the really good stuff, I just want to take a brief moment to talk about a few housekeeping items. For today's Q&A and poll questions, so this is going to be an interactive session where you can submit your questions as well as participate in our poll questions all through Slido. If you still need to log in, you can go ahead and scan that QR code on your screen, or you can go ahead and log in directly through our live streams hub page. Also, at the end of this event, we are going to be launching a survey also through Slido that's going to have just a few set of quick questions, and we would really appreciate your feedback about today's session. We always look forward to your comments. And all right, so but without any further delay, we are pleased to welcome our star speaker for today. We have Threat Intelligence Lead Pierre Cardew. He is going to be leading us through this presentation today. It's going to be covering defense in-depth strategy, security monitoring tools, and technologies. Good morning, Pierre. How are you?
Hey, Brigo, I'm doing great. Thank you.
Thanks. Awesome. So, Pierre, I think we are ready to dive in into the today's topic. So, if you're ready, please go ahead and take it away.
Okay, thanks, Rigo. As Rigo said, good morning, good afternoon, good evening to everybody who's joining us on this training session today. Today, we're going to be going over the topics of defense in depth strategy, as well as security monitoring tools and technologies. First, a little bit about me. I'm located in Los Angeles, California. I've been an information security professional for over 26 years. I was in the role of CISO twice for various financial services organizations and a former consultant with a couple of well-known global consulting firms. I also was former head of Talos Incident Response for a number of years, helped them to build up their practice and helped lead investigations as an incident commander and as a manager as well on the team. And I've recently moved over to the threat intelligence and interdiction team, leading threat intelligence advocacy for us over at Talos. So the topics for today are defense in depth strategy and security monitoring tools and technologies. We're going to go over these two topics, which are related. There's a lot of interlinking, and you'll notice when I'm talking about one, I may have references to the other as well. So, starting with defense in depth strategy, we're going to go over the background and definitions of defense in depth, how this came to be, what it means to us, and how historically was referred to and as a tactic and a strategy as it originated, and then how we then interpret it for cybersecurity. Then we want to look at the evolution of it as well and how we can then apply those ideas and principles to architecture as we build new environments or as we assess environments that are already existing. We also want to then look at the links within defense in depth to monitoring and alerting. One key component of defense in depth is monitoring, active monitoring. Then we'll move over to more focus on security monitoring. We'll talk about some of the various tools and technologies, the background and definitions of some of these as well, discuss where and why and when to monitor, and we'll review some output of monitoring and alerting, and also walk through a practical example related to an incident that was investigated in the past, which is a ransomware incident. So we're going to walk through the types of technologies and telemetry that were most useful or would be most useful in the event of preparing for investigating a ransomware incident. So we're going to first talk about defense in depth strategy, which is again a layered approach to defense. In history, this was originally a military strategy focused on layered fortifications using units and fallback points that were established and used to delay or degrade attacks. The key objective here is to cause delay to the adversary. So we're not in this usage of the strategy, not attempting to create victory. We're attempting to delay and degrade the adversary. So if we think about this from a historical perspective, a classic example of this is a castle. So we look at the castle and the function of a castle and the different defenses within the castle, and they create a, again, defense in depth or layered security strategy. We start by looking at the shape of the castle and the way it's laid out. We have a defensive moat around it, which prevents casual access to the castle grounds. We also have a single or limited entry point that we can control access to. We also have a way of checking identification and authorization at the guard checkpoint here, the guard checkpoint at the front gate. So we have a known limited entry point where we have some sort of authentication validation. We also have watchtowers that are distributed around the perimeter of the castle to look for any attempts at bypassing the moat or the walls. And then we have maybe a rotation of guards that within there that are watching each other and making sure that there's no gaps in coverage as well. And maybe there's also communication between the gate to the watchtowers. If there's something suspicious of the watchtowers, then maybe the gate becomes closed. We also have an inner wall here that segments off the outer courtyard and the inner courtyard where the keep is at. And this additional inner wall provides a subsequent observation point. So we can have more observations from here and the wall inside, as well as additional validation point for access control and identity. And then we have our most secure section here within the keep, where we have maybe additional controls, additional monitoring, etc., and maybe even yet, and again, a different entry point requirement for identity. So the concept again starts with these layered controls and defenses. We have many controls which can fall back to each other. If there's a adversary trying to come in through the moat, the watchtowers may see them. They would then close the entry points, and they may be able to have a counterattack or defend themselves. If somebody breaches the inner or the outer courtyard, then the inner courtyard can be locked down and then secured appropriately to prevent access further within there. We're creating a segmentation of territory to deny the adversary quick access to the environment. And if they win one section or take over one section, they're not going to take over the entire place. Again, so having those segments and layers. So now twisting this over towards cybersecurity. How does this apply to cybersecurity? So here's the definition from NIST. This is an information security strategy that integrates people, technology, and operations capabilities to establish variable barriers across multiple layers and missions of the organization. So I'm going to parse through this really quick. So starting off with the statement of this is a strategy that requires people. So we need to have security monitoring individuals and capabilities. We need to have individuals or people monitoring the as watchtowers. We need to have somebody who can be escalated to if we see an event, if we see something happening. There needs to be people that respond and can do the actual active defense. We will use technology like monitoring tools and identification tools, et cetera, to come up with detections and then to validate those and correlate those. And then we're going to have an operations capability that exists, which means to have a process and a capability of knowing how to escalate an alert and how to then evaluate it or investigate it if necessary, if it's an alert that needs to be further investigated. We also want to have variable barriers. We want to make sure that we have the right kinds of controls. We need to have firewalls. We need to have access controls. We need to have authorization and identification processes as well. And we need to make sure that those layers are maintained and established. And this is, again, an ongoing process. And it has to tie into the mission of the organization. So we have to understand the organization's core mission, making sure that our security controls match and accentuate that. So I mentioned controls a few times. I want to go through a little bit about what each of these control types mean. So we have two different main types of controls. We have detective controls, which may identify and observe, and then we have preventative controls, which can stop known bad things from happening. They're related, and there's some overlap there, but classically, you may have environments that have tools deployed in a detective or alert-only mode, and so that's what's here on the left-hand side. They're helpful for understanding what normal is, to help to create a baseline of telemetry to understand how things are working within your environment, what the normal pattern is for logging in for users, what the normal pattern is for how much data they transmit within the organization and inside and outside the organization. Those things can be helpful to build a baseline for you so you can look for anomalies outside of that. These controls can also provide additional correlation points for other detections. If you find a detection of a malicious piece of software on a system, that's the only thing you know about it, that it was detected and quarantined. That's a piece of knowledge, but it doesn't necessarily help you understand the whole actions. These detective controls can also help to enrich that and maybe let you know the actions that were taken before the malware was found. Where did it come from? It was downloaded from a website that was known as malicious. Was it downloaded from an email attachment, etc.? Just checking, Rigo, can you go ahead and make sure you're muted as well? Getting some crosstalk there. Okay. Um, the detective controls again can also be useful for identifying previously unknown activity. So if we have a situation where there's an adversary using a new type of attack or new type of telemetry that we weren't aware of that we're collecting, but we haven't necessarily put it into our detection rule set, we can search through for these detective controls to see if we can find this telemetry and then maybe start to apply it towards the detection as well. And maybe there's a pivot point that adversaries are using a new method, technology, or technique that we weren't aware of or we weren't monitoring for, but maybe it's in our logs. We can find it that way. And these detective controls must be monitored actively to be effective. This could be a combination of human monitoring as well as automation, and should be a combination thereof to use automation to help to scale the monitoring, but there should always be a human in the loop there. Moving over to preventative controls. Again, this is where we can stop bad things from happening based on detections. We can enforce our security posture by blocking known bad activity, whether it be known bad malicious files, whether it be known access to malicious or identified as malicious domains, email addresses, etc. We can use this to block, again, known bad traffic, email files, destinations, etc., depending on the kind of controls we deploy. We can isolate or quarantine files, devices, or entire networks if we configure it, if we have a high confidence in the detection. This can be especially useful in the event of an incident where you're trying to stay ahead of the adversary and you know the tools or techniques that the adversary is using. You can set up a rule to isolate devices based on detection of these things that are being used by the adversary today. So again, we can look at the tool capabilities and see if it has the ability to do isolation. And if so, then we have a high confidence of a certain detection. We want to make sure that any system detected with this behavior or this file can then be isolated immediately. And then alert is sent out to the security operations team so they can then remediate that device. This may use behavioral activity as well to identify suspicious behaviors and prevent it. Behavioral activity is something that, again, crosses over between detective or preventative, but usually the behavioral activity can help to raise the confidence level on a detection to make sure that it's not just a false positive, that it's also an outlier of user behavior as well. There's also, as I mentioned, a chance of availability issues. We want to isolate and quarantine things that we have high confidence on. If not, we may create a situation where we have false positives, where accounts or devices are being incorrectly isolated or blocked. This could happen and has happened in the past, and is something that we always need to be aware of and know how to remediate immediately. So it's not something that should prevent you from using isolation capabilities. You just need to be aware of the process to reverse those and be able to unlock and to disable the quarantining of these devices. Going to talk a little bit more about the fundamentals of defense in depth. This goes back again to sort of philosophically about why defense in depth could be useful and the types of aspects we expect out of a defense in depth approach. So, again, we talked a few times about layered controls, the idea of overlapping control zones where you have the different observation points. If we use the castle metaphor, where you have the different watchtowers, you have the different controls like the drawbridge that secures the moat and can be pulled up, the moat around there to prevent casual entrance, etc. Those layered controls, the same sort of thing applies to cybersecurity. You want to have a firewall at your outmost perimeter. You want to have routers that also collect net flow below them so you can see more traffic data east-west. You want to have a configuration of your user environments that's hardened, and you want to make sure that you're monitoring those user environments. You make sure that you're monitoring your authentication environment, that you have other controls deployed. So those controls, again, should complement each other and help to give different perspectives and different views into the same activity. So you know that a network connection came inbound from the firewall, ended up at a user system where the user was opening a website and it was known as a bad website, therefore it was blocked. And then some action was taken on the device to do something else. You know, these different logs and stuff can again help to illuminate the process of your investigation. We also need to have redundancy. It's important to have redundancy in controls and in architecture for disaster recovery perspective, as well as from a load perspective. So making sure your controls are redundant and that you have a fallback point in the event that one of your controls fails or that your logs are unavailable in one aspect. Especially if you're dealing with a ransomware situation or a situation where you're dealing with an active adversary, you may have them target your log files and they may either turn off logging or destroy the logging. So you need to have some way of getting historical logs as well to look for prior activity, etc. Describing again the castle metaphor, we want to minimize potential adversary impact. So we want to look at the way that the layers are set up with regard to the walls and the segmentation. Same thing applies to cybersecurity. We want to make sure that we have different segments and layers to prevent the adversary from casually getting in. So maybe that means different authentication schemes or different groups or different ways of doing authentication there. We want to have multiple observation points. I covered this a little bit earlier, but that helps to build up the full picture of the environment in the event that you have activity that you're trying to investigate. Segmentation, again, goes back to the minimizing the potential adversary impact, but having discrete segments for especially critical systems helps to protect and also provide a different observation layer when you have known good traffic coming into these observation to the core systems, for instance. You can then monitor that and have a baseline for what's normal, and then you can see the attempts by users to come in that maybe shouldn't be coming in. You could then use that as a trigger point for an investigation or to find that there's some anomalous behavior that needs to be considered. And this goes back to the correlation of telemetry. A login event by itself isn't necessarily a threat. A login event by an account that you know was compromised or exposed via a phishing attack is something that should be investigated. So having those other pieces that make that alert more interesting or understanding the context of it is helpful for you to understand when things should be escalated, as well as when how to do better investigation. So you know again the full activity related to that transaction. The concept of zero trust has been used a lot in marketing, and I'm not talking about that aspect of it. I'm talking about the sort of basic idea that every user and device needs to authenticate and be allowed on the network based on some sort of authentication process. When you plug a device into the network, it needs to be challenged and either isolated or authorized based on its response. When a user logs in, they have to then be authorized and given the correct authentication and authorization, or they need to be isolated, or they need to be treated in a certain way that's appropriate for that user. There should be some sort of an interrogation of the devices and of the user, and then giving them the correct credentials to be able to get to those various segments. If you give every user access to all the things all the time, you don't really have a segmented environment that allows you to have multiple control points. You need to have that zero trust as an initial process for validating the devices and the individuals. And this also can apply to non-human users as well if you're talking about agentic accounts or if you're talking about service accounts. We often use service accounts today already within the environment that are non-human related accounts that are used for things like backup, printing, etc. And those are often used by or leveraged by adversaries during incidents. So making sure, again, to consider the ideas of zero trust and enforcing that is crucial to effective defense in depth. A basic control about security, and definitely a part of defense in depth, is hardening devices. Making sure that these devices have the minimum footprint necessary to do the role that they need to do. If you have a new server installed, it shouldn't have extra services running on there, like a web server or other communication services, etc. It should be minimized to only be able to perform the function it has. This is easier with a lot of the more purpose-built like Kubernetes type deployments and the cloud-based sort of things. But there's a lot of legacy software and hardware out there still that we're dealing with, and installations of servers that may have configurations that are not necessary. So harden those devices by removing those additional components, as well as making sure that any other hardening steps such as patching, maintenance, and configuration are set up so that it's going to be ultimately as secure as possible when deployed. And then that's going to be an ongoing thing you need to do, which goes over to the next item here, timely maintenance. Making sure that any new vulnerability that comes up is addressed. You have a process for assessing those vulnerabilities as they're released by the vendors. So you know when a new vulnerability has been released. You know how it applies to your environment, and you know you have a schedule or a plan for applying it, or you have a understanding of when you should and should not do that. Maybe there's internal testing that needs to happen first. Maybe you have a process where you only have a change window on a certain periodic basis, and you have a mitigation you can do in the interim. So timely maintenance doesn't mean patch everything immediately. It means have a plan for how you apply your patches and how you apply your security changes as well. It's not just about patching. Some of these vulnerabilities that are identified could be because of a misconfiguration. Maybe a prior configuration that was identified as being secure at the time no longer is, and it has to be reversed. Shifting over to this network security diagram, this is a fairly generic and high-level diagram intended to walk through the concept of defense in depth at a sort of a system level. So looking at this diagram from the outside in, from the top, we have the general cloud identified internet icon there with a generic cloud icon to the right of it. And then we have the intra domain services next to it. So that's this layer here. And this layer is really the outermost layer of this structure, where we have, again, the internet ISP connection. We have that generic cloud, which could be software as a service type of provider, let's say a cloud-based HR system or cloud-based payroll system. And then we have to the side there, the Entra domain services, which is the authentication system from Azure for Microsoft. So you'll see the dotted lines there where, for instance, that generic cloud also connects into the Entra domain services. So it uses that for its authentication. And then the dotted line that comes further inside on the left side from the Entra domain services, where it goes back down into our internal network to directory services. So this goes to our Active Directory. So this layer, as an example for controls, we want to make sure that we're looking at the firewall and looking at the configuration of the firewall, allowing in only the traffic that we need that's appropriate for the business we have, and also outbound. Outbound firewall blocking is a crucial part of security and needs to be considered when you're deploying a firewall. Many times configuration is kind of shortcutted and looks only at inbound traffic. We need to also be considerate of outbound traffic and limitations of that, or things we need to do to secure the environment to prevent casual use of, let's say, legacy protocols that we don't support or don't want to use. And someone's not muted. I'm going to just ask again so we can mute real quick. Thanks. Moving on to the next layer, we have the classically referred to as a DMZ network, which is the next most layer behind the firewall, where we have this web server placed here as well. So this web server is, it's say, an internet-facing web server that's providing services for our customers, and we have this firewall, which again has a offshoot point for it for the web server to live. And so this provides hopefully as close as possible network connectivity to the internet for this web server. Uh, so again, from a control perspective, we want to make sure we're understanding the traffic that's coming through the internet to the firewall and to the web server. We're not going to allow all traffic and all protocols to come through. We're going to limit it to the normal web server traffic, so port 80, port 443, et cetera, coming through the network to come in. And we're also going to make sure that there's not anything other than the reverse web server service being sent outbound from the web server to the internet. We don't want to have ability for somebody to possibly launch something from the web server and come back in from it, or be able to do any sort of remote logins, etc. This server, of course, should be hardened as well and monitored. There should be logging from that sent into the logging server. And there also should be different authentication for that web server than the next segment here, which is our user network. And so our user network, this internal devices section here, for instance, indicates our user laptops, desktops, etc. And then we have our directory server and radius server. So the directory server being an Active Directory server for Microsoft, and then radius server, which is used for authentication for other devices like the firewalls, routers, etc. And again, we have, from a control perspective, we have a separate firewall here that's linked off the initial firewall that may have different authentication or segmentation controls. Maybe only users and the company here can access these servers here, and maybe they can access an additional part of the network, but maybe they can't log into the web server, or they have reduced access of what they can access to the internet. Maybe certain things that are known bad are blocked, or certain types of web categories are blocked as well. If I look at the core server network here, which is a database server, mail server, and a data transfer server, again, we have a situation where we have multiple firewalls that are segmenting this network off from other segments. There's a firewall there between the core segment and the user segment, as well as from the test network to the right and up towards the internet as well. So all those present different observation points, as well as different segmentation opportunities and different enforcement points with regard to logins and authorization, etc. We also need to make sure, of course, that the traffic is allowed inbound and outbound for things like the mail server. That the mail server is able to connect to the internet where it needs to be able to send and receive email, as well as other functions like this data transfer server. And finally, we move over to the test network here on the right, which has a test server environment, a test router, as well as a VPN server. Now, architecturally, this may be a little bit confusing, but we have the VPN server here, but it then terminates onto a firewall, which would then help to make sure that this network is hopefully secured, and there should be specific authentication for this. And it needs to make sure that we have, hopefully, multi-factor authentication, since it is effectively going to bypass our security controls that come through our normal firewall port. So this should have MFA as well. So walking through this again, we have multiple layers and different observation points. This creates a similar sort of situation like we have with the castle diagram. And it also has different enforcement points and has different zones of control that hopefully prevent an adversary from coming in and bypassing these controls. Now, again, this is just notional as far as a conversation to give you an idea of the kind of things to think about from defense in depth. You would then want to apply this to your environment as you're architecting a new environment or assessing an environment that you're control or responsible for, and making sure that you have those controls that I've mentioned, and that you also can look at the controls that are appropriate for the kind of business and the kind of environment that you're dealing with. No security strategy is complete by itself, and defense in depth has a number of weaknesses which we have to consider as well. The controls must be maintained and executed as intended. It doesn't help an environment to be secure if we have environments that were deployed or servers that were deployed and hardened at the time, and now 3 to 5 years later, they've never been patched, or they've never been hardened again, or they haven't been updated with their operating system, etc. Or maybe they are no longer necessary and should be deprecated. So we'll make sure that devices in our environment are actively assessed, maintained, and these controls are deployed and executed as intended. Moving over to the right side here, layer detective controls only work if monitored properly. So we talked about the layer detective controls a couple slides back. Those require active monitoring. So it's important that we have some method, whether it's a combination of automation as well as manual efforts to do that monitoring, and that those logs are retained for investigative use later on. It's important to recognize that controls may be bypassed. In that diagram we just talked through, for instance, the VPN server is a possibility for exploitation. It could be exploited by adversaries and misused if not properly secured. And then it bypasses a number of the other controls we have in place. There may be other things that are deployed in an environment that may bypass a control. Or adversaries may use new or unpredictable tools or techniques to compromise environments. It's not so much that adversaries are using new unknown vulnerabilities, so much as they're exploiting unpatched, unmaintained vulnerabilities most of the time. Most of the incidents that I've responded to in the past 20 years of working on such things have been related to systems that were out of maintenance and that adversaries just checked to see if there was a vulnerability and they could exploit it, and they could, and they were in. Obviously, that's maybe simplifying things a little bit, but uh, in some respects, adversaries are lazy and only do the minimum necessary to get into their environments, especially financially motivated adversaries, which are usually trying to get things done very quickly. So making sure that you have your environment maintained correctly will help to deter them as well. But there may be a new methodology or a new vulnerability that's been announced that you may not have yet secured against or patched against that adversaries can use. So be ready for an incident. Static defense cannot succeed versus a dynamic attack. Part of the mission of my conversation here with you today is to make sure that you think about attack and defense, both as being active processes. Adversaries are actively going to be attacking your environments. And so as a defender, you need to have an active defense. That means having active monitoring, active assessment of your controls, validation of your security posture, testing your security posture frequently. So talking a little bit further and finishing up the defense in depth section here, it's important as defenders to architect environments that are defender friendly. We want to understand the best ways to defend these environments and collect the telemetry and the logs that we need to answer the questions that we encounter. So if you think about during an incident, what kind of questions are you going to be asked? Was this file executed? Did this user log in? When did this user log in? Where did they log in from? Each of those questions ties back to different types of logs and log sources. Knowing that and having a map for where to go to get the answers to those questions is a big part of preparing your environment for an eventual situation where you're going to be defending the environment actively. So, an incident response. You need to make sure that you think through these questions and understand the linkage to the telemetry. And if you know that you have it, know how to get it and know how long it's retained for. So you can answer the question when your stakeholders come to you and say, who logged in on this box 6 months ago? Maybe you have those logs. They ask you the same question, who logged in this box 2 years ago? Maybe you don't have those logs. And you need to be able to say with confidence what you do and do not have. Continue to identify opportunities for additional controls or monitoring points. The controls I talked about today are based on today's threats and today's techniques that adversaries are using. Threats and adversaries adjust over time. They'll continue to morph and use new types of threats and attacks and new technologies and techniques as we go along. There'll be different things a year from now, and there'll be even more different things 3 to 5 years from now, where adversaries are using maybe tools that were embedded and found to be insecure or new vulnerabilities that have come up, etc., that I haven't even thought about. So it's important to look at the different types of attacks that are occurring. This is where you can tie in your threat intelligence. Look at the different types of attacks that are occurring and use that as a guide point for making sure that you have the right technology to defend your environment. Next item here, security requires maintenance. Part of security is going to be the responsibility to maintain your devices, maintain the software, the configuration, make sure that they're updated and resolve new vulnerabilities. Look at the hardening requirements and resolve any other weaknesses. Sometimes the weaknesses aren't patching an operating system or patching an application so much as it's maybe disabling a service or changing the configuration of something. Let's say, for instance, for PowerShell. PowerShell works just fine, but it doesn't by default enable the logging necessary to do investigation of PowerShell. Now you can do that fairly easily with a number of different ways, but by default, it doesn't necessarily turn that on. So it's important for you to make sure as you implement different software that you also make sure that it's, again, looking at the first item here, maximally helping you from a defensive perspective, providing you the telemetry you need to be able to secure the environment and investigate. You should do periodic controls assessments and red teaming of your environment to test your defenses, and then implement those recommendations and resolve the vulnerabilities identified. If you have a report that has a number of recommendations and you've never taken action on those, that's going to be on you when that comes up. So it's important to make sure that you've at least assessed that from a risk perspective and understand your approach to that. And maybe you can make a risk informed decision about maybe you can't do something, but it should be something that's consciously assessed. And I've said this a couple times, but I'll say it again. Defense requires monitoring. Many of the detective controls that we've talked about that help enrich or correlate other alerts don't function without some sort of a security operations function. These detections may not be investigated fully without some sort of monitoring. So it's important to clearly document when and how issues should be escalated within your security operations structure, where a alert goes from being an observed alert to being an investigated alert by maybe tier 2, tier 3, and then when it gets escalated from there to your IR team or for your investigative team to look at. And have a known or tested process for triggering an investigation. Once something gets to the point where it's bigger than a breadbox or bigger than a situation that you can handle within your security operations center, and you need to then inform leadership or inform stakeholders or bring in other investigators, you need to make sure there's a clearly documented incident response plan for doing that. I'm going to shift over now to talking a little about security monitoring tools and technologies. Again, we've already talked a little bit about that as it's linked very closely with defense in depth. So, why do we need to monitor? It's important to provide active analysis, response, and investigations to detected suspicious and malicious events. We want to make sure that we are doing our responsibility of watching our environment. In many environments, this is necessary. So you're securing your environment and you're watching for anything that might be happening that might be indicating malicious activity. Some aspects in some companies or some enterprises, this could be something that's required by your compliance laws as well, because of the data you handle, the type of business you do, or maybe you have fiduciary responsibilities because of the type of business you're in. It's important also to collect the telemetry for monitoring for use in future investigations. Most incidents happen and then are detected weeks, months later. So the telemetry that you have from this past summer, for instance, now that we're in October, this telemetry we have from this past summer is going to be necessary if we have an event that happened in May, June, July, August, September. All that telemetry needs to be understood as far as how long you keep it, how long you retain it for, which logs are kept, etc. So that's useful though for looking at investigations that happened backwards looking. Similarly, we want to look at things going forward for threat hunting. That telemetry that we get from our monitoring helps to inform or helps to provide us a way to do hunting across this for maybe unexpected activity that adversaries might be doing, or ways of validating our detection controls to see if there's any detection gaps. I'm now going to run through the different types of telemetry related to an incident that I helped to handle a couple years ago. This is a standard ransomware incident. And this incident, again, started off with initial access and ran through these different phases: initial access, user actions, account compromise, privilege escalation, lateral movement, and encryption of data. This is a standard attack sequence for ransomware, and it's similar to what's happening today as well. There's a couple differences in some of the tooling, but the telemetry I'm talking about here is very much applicable to today's configurations. So this gives you an idea of the kinds of monitoring and tooling that you might want to consider for something like this sample ransomware incident. So starting off with initial access, it's important to have a valid and functional email inspection. Many times adversaries will enter an environment using an email lure or some sort of a phishing attack or phishing attempt. So understanding your email flow, what kind of email you come in, making sure to block known bad sources, making sure that there's some sort of inspection of attachments for email, etc. That is crucial. And then you need to make sure you know how to manage those things. If you see a bad attachment, is it automatically quarantined? Does that then do a retrospective search across the whole environment to see if there's any other indications of that same file being present, etc.? Understand your log retention. We talked about this a little bit already. You need to make sure that you have the right logs for authentication, for user access, for activity on systems to verify what happened when that email was received. And you need to be monitoring those logs as well and creating a process for alerting on anything that's suspicious. If this originated from a phishing email that was a file that was downloaded by a user and the user launched it, and we have that telemetry, and then the launching of that subsequently pulled down a different tooling, we should be able to see that activity in our logs. Hopefully, that would then create some sort of an alert that a new malicious tool was downloaded on the system and was either executed or attempted to be executed. And that then helps us from an investigation perspective, hopefully to catch this earlier. But if not, at least it helps us to understand the initial entry point from the adversary as well. Moving over to user actions, this is again the section where the adversary or the user could be performing actions. Maybe this is when they opened up that file that they downloaded from that phishing email. They clicked on it and it made a web connection to a site, and this would be found in DNS logs. Maybe then subsequently there was connections from this user workstation to a server, which might be unexpected, and that may be found either with authentication logs or possibly with NetFlow, depending on the kind of data that we're seeing. It could be a situation where there was a large transmission of data from the server to the user workstation, which might be, again, out of bounds of a baseline, but would then be able to be identified by monitoring in NetFlow. The endpoint security solution should also be able to help us identify the sequence of events that happened with regard to the launching of the file, what the user was doing immediately before and after that. Perhaps the user saw the email, downloaded it, clicked the link, or downloaded the file, executed the file, did a thing, and then didn't do anything for a while. And maybe then the adversary used that account somewhere else as well. We can then see that information and maybe the capturing of the credentials as well. The endpoint security solution might also be able to quarantine that system. If it says, hey, this is a known malicious binary, I'm going to quarantine the file and alert somebody or quarantine the whole system. Having a tool like Sysmon deployed helps to enrich the logging capabilities of most Microsoft environments. We strongly recommend the deployment of Sysmon. It provides a number of different logging events that aren't based in the normal out of the box installation of Windows servers or Windows devices. So definitely consider deploying Sysmon to help enrich your logging and give you more events to be able to look at when you're doing your investigation. Also, make sure that you have your PowerShell logging configured correctly. PowerShell is a very powerful tool that's used quite often by adversaries to perform activities. They often will obscure it by doing some type of encoding to it as well. So knowing how to collect those PowerShell script block logs and knowing how to then possibly deobfuscate them is another skill you should consider looking into. Moving over towards account compromise, hopefully they have multi-factor authentication deployed because that will help with preventing perhaps the account compromise. But there are a number of attacks or ways of getting around multi-factor authentication as well that we have to be aware of. If the adversary already has administrative access to the environment, for instance, they could modify the configuration of the multi-factor authentication system and exclude that account that they just compromised. Maybe that account now doesn't require MFA, or maybe they then authorize a different device to be able to be a authorization point for MFA, or they use a bypass code or generate a bypass code, which then they use to log in. There are a number of different bypasses that are possible, depending on the access the adversary is doing and the awareness of how to attack MFA from the adversary. We always want to make sure we're looking at the authentication events, both failed and successful. That helps us to understand the behavior of both the normal behavior of the users as well as then any anomalous behavior we see where a user is trying to log in outside of normal work hours from a geography that may be unlikely, etc. Looking at the creation or modification of groups is an important part as well that adversaries may try and manipulate. They may see the administrative group within an environment and try to add accounts to it that they've compromised, or maybe remove accounts. In one incident that I helped work through, the adversary was dealing with an active defense from the defenders on the security team, and they had access to the Active Directory. The adversaries, were able to remove all of the security team members from the domain administrative group, and left themselves only as the domain administrators, which totally locked out the defenders. The defenders, in the end, had to rebuild their environment from scratch and basically tear down the environment that the adversary had taken control over. That was a non-trivial task and took a lot of time. And the adversary essentially had won that round by doing that. So understanding and monitoring for group modification is important to see if something like that's happening before they get to that point. Of course, making sure you have MFA and other authentication controls in place is super important as well. Continue to look for unlikely and suspicious behavior as well. Those unlikely events that I mentioned before, as far as geographically unexpected logins, maybe work logins out of cycle, maybe someone's just working late, maybe someone's on travel. Those are valid, but they should be validated. If you have that sort of thing happening frequently, maybe it's something that's worth investigating. Moving over to privilege escalation, there's a tool that Microsoft releases for their operating systems called the LAPS tool, which is Local Administrative Password Solution. This tool allows you to have a local password for a Windows operating system that is tied back to Active Directory, so you don't have to have a static hard-coded password for each device. And this allows the passwords to be secure because they're going to be different on each device. Classically, in many environments, the approach for deploying a Windows operating system is to use an image with a built-in or a established local administrative account that's the same on every system. Then, if the adversary is able to compromise one, they can move across and compromise the next one as well. That makes it very, very easy for an adversary to move over with a known good account that gives them administrative access, moving from system to system. It's a very bad thing. So consider deploying Microsoft Laps if you haven't already, or looking into how you manage your local administrative accounts. I mentioned this a little bit on the prior section, but monitoring your privileged accounts is crucial to securing them. This also covers agentic and AI accounts as well, not just service accounts that are run by the operating system. If we're giving access to our environment to a non-human entity, we need to monitor it as well and as thoroughly as we do with our service accounts today, and making sure that the privileges are allowed for the things it needs to do, but maybe removed from some things. Maybe, for instance, some of these accounts shouldn't have administrative access on all servers. Maybe we need to be more diligent about removing their active ability to an interactive login. So you can't interactively log in with this account, but you can use it programmatically. And then you can only use it programmatically on these 1, 2, 3 systems that are appropriate for this role of this account. So we need to do some analysis of this as we architect our environments. We also want to alert on and monitor for GPO modification. GPO is the group policy object which manages the configuration of software, devices, security controls, etc., within an Active Directory. This is a very powerful tool that can be used to change the behavior of systems, and adversaries know how to use it. Adversaries will often modify this to change the security configuration of a device to remove things like the endpoint detection tool, or to remove capabilities that will help to defend an environment, like the volume shadow copy or other things, as they're preparing for ransomware in this case. So alerting on GPO modification may help give you an early understanding of the adversary's techniques and hopefully give you a way to stop or prevent that from happening and getting further down this attack chain. Adversaries will move laterally through an environment, so it's important to consider configurations like network segmentation, which we talked about extensively in our last section. Remove or restrict the use of the SMB protocol. There's no reason necessarily in this day and age for devices to talk SMB to each other. Within a user network, laptops shouldn't be talking to each other via SMB. They should be sharing things off of a centralized share system, centralized file system, etc. Um, and the use of SMB is, again, something the adversaries love to do for moving files around. It should be something that should at least create an alert and probably be prevented in most environments. And you want to monitor for unexpected traffic. I don't know how many times I've seen large amounts of data transmitted outside of the organization from inside that wasn't detected until we looked at it later on with NetFlow. If you're looking at your environment with NetFlow and have a good baseline and you're understanding where things are outside the parameters, you should be able to see that as it starts to send large amount of data. If the adversary is sending 2 terabytes of data out to a pastebin site, you should be able to detect that actively by doing your monitoring, collecting your logs, looking at NetFlow, having a baseline, and validating against it. It may be difficult to establish that point, but it's important if you're worried about data exfiltration and data theft to have those tools in place to answer those questions. How much data was sent? Where did it come from? What data was sent? And I've also seen adversaries many times use legacy protocols, such as old FTP, port 21 classic FTP, to send data outbound. If you don't need or support those older protocols, you should block them at the firewall and have some sort of an alert that lets you know when someone's trying to use those protocols that are no longer supported or that you don't want to support. This would help you hopefully catch that information before it goes out the door. Since this is a ransomware situation that we're talking about notionally, we're going to end with encryption of data. So it's important from a data management perspective to ensure that your data is backed up. I can't stress enough that it's important for you to also have that data in a different segment or different authentication segment than your normal network. If we assume through the account compromise phase that adversaries have already accomplished the goal of compromising your Active Directory, and then during privilege escalation, now we know they have domain administrative access. They have access to all of your servers. If your backup server is a server on that same network, they have access to it. Adversaries are smart enough to identify where backup servers are and what their function are, and they will target those intentionally to try and degrade your ability to recover. This is a common occurrence. So it's important that you have those backups collected and that you have them securely stored and validated that you can restore them as well. The restoration of data may sound easy, but it's something that if you don't test it, you don't necessarily know that it's going to work. So not just ability to get the data back, but does it then also what steps are needed to get the application running as well? So think about it not just from a backup perspective, but a little bit of a disaster recovery and business continuity. Can I recover this, and what steps are necessary for me to then rebuild my environment? So we're going to talk through some of the architectural decisions with regard to detection and monitoring. It's important, again, to design your environment to allow for response and investigation. We touched on this a little bit earlier as well, having the concept of a defender-friendly infrastructure. Understand your assets, your risks, and your blind spots. Understand what the business objective is. Understand what systems you have deployed, what systems are necessary for adversaries, or sorry, for your customers to access, what risks exist in those. What maybe you know it's running a version of Apache Tomcat that has vulnerabilities and you have to patch those. Maybe it's running a database server that has a vulnerability as well, or what blind spots you have. If you think about it from, again, that the layered perspective or the castle perspective, where aren't there overlaps with regard to your observation points? Maybe you need to consider improving that. Know where your logs are, where they're retained, how to access them, and how long they're retained. Those questions will help improve your ability to respond to an incident and help prepare you for those conversations with your stakeholders on how and why something happened. Know how to deploy tools rapidly in your environment and the impact and processes involved. Software deployment in an enterprise can be tricky. It can be a difficult process. It requires change control. It requires a lot of people to help out with things. It requires understanding of the impact of things. There may be some testing processes as well in your environment, but know what the process is in the event of an emergency. So when you have to propose such a thing, you know what it is you're talking about. And you can then answer the questions that your stakeholders bring up to you about the how and the why. Most environments will require some level of monitoring. It's important to prioritize the alerts we get from security instrumentation, where we have a confirmation that something is malicious. That should be prioritized. And then we would use the other items that help to enrich that to correlate. This could be done with SOAR or other types of automation, or possibly with AI. Know what your critical systems are, what the critical users are, environments, etc. So thinking about it from a standpoint of a normal um, manufacturing organization, you need to know that there's critical systems. There's a shop floor where there's a mechanical process that builds widgets. It actually runs a robot, and the robot control system runs this certain operating system, and it's in its own network segment. So we have a sales portal where customers come in and buy something that's internet facing. We have a distribution system portal where the labels are all printed, and that goes then to the robots, which then create the widgets, and then there's a process to box them up, etc. So understanding the business flow helps you understand the criticality of each of these segments. So if you know that there's a problem with the label printing system, you know that affects things downstream from the shipping and receiving and the eventually the manufacturing floor as well. So this is also where you consider your threat intelligence. If you know that there's a vulnerability in a software which you use in your environment, let's say part of your mail system uses a database which has a recent vulnerability. You want to make sure to be aware of that impact for you, what you're doing to mitigate it, and if you need to apply a patch, you start that process. You also want to look at it from a standpoint of what other adversaries are trying to target in your region, your geography, and in your vertical. So you can understand the types of threats that your peers are working with and that other people within your organization and your company are dealing with and worried about. Also, have those conversations with your leadership so you can understand from the stakeholder perspective what their biggest concerns are. And that way you can help to support them to address those concerns and hopefully get their support on the decisions you want to make with regard to your security controls. And understand how all of this links to and supports potential emergency investigation. Inevitably, all of this comes back to I need to investigate a thing that happened. And preparing yourself along the way by having the right telemetry, having the right layered defense will help inform that decision and make that investigation be successful. So now, Rigo, we're going to go ahead and switch over to the Slido. And this is a Slido question that I asked Rigo to set up. So let's go switch over to that.
All right, awesome. Thank you, Pierre. So that new poll question is now live. So we'd like to know from the audience here, what are the top controls you would want to have deployed in a new security architecture? Go ahead and type in your answer. You can go ahead and scan that QR code on your screen if you're not already logged into Slido, and you can type in your answer to let us know what you think the top controls are. And
Great.
yeah, we got one out in there already.
Okay. What we can do then is we can let folks respond back into that, and then we can address that as we get into the QA section. We can pull that back up and look at that together. So take the time now to go ahead and fill that in as I wrap up this conversation. So moving on, one other thing I want to make sure to hit on, which is important concept to think about when you're looking at detection and monitoring. There are some languages and some sort of rule sets that you want to be familiar with, how they work, how to create them, how to assess them. There's three different ones that I specifically want to call out: Snort, Yara, and Sigma. These are each valuable rule sets that can be used to create detection capabilities. If I look at Snort, for instance, it's a common method of creating network detection rules. Uh, Obviously, it's part of Cisco's repertoire. It's an open source tool that has existed prior to being acquired by Cisco, as far as like the SourceFire organization. But Snort itself is still a open source and tool that you can use. And many software deployments or hardware deployments of different types of firewalls, et cetera, leverage Snort rules. It allows you to deploy Snort rules in network detection devices. So understanding how Snort rules work, how to make them, how to assess them, and what tools and devices in your environment support them gives you some flexibility in creating custom rule sets if you need to then look for certain traffic based on an incident you're having, based on a threat you're concerned about. So be familiar with that. Looking over at Yara, again, a similar sort of common language for using to create searches for files and file systems for specific behavior. This can also be used for looking at memory extracts as well. This can be used with email security systems or any place you need to look at a file to see whether or not it matches the known behavior or known file type that you're looking for. And you can configure that to be fairly specific, or you can also look for things on a more generic level. There's a lot of open source and shared rules that you can leverage from a Yara perspective as well, looking for certain types of behavior. Definitely suggest learning about Yara and being familiar with how to use and where you can use Yara in your environment. Similarly, there's a rule set called Sigma. Definitely recommend being familiar with how to write Sigma queries. Sigma is a vendor neutral YAML rule set that can be used to search across various different SIMs. So, for instance, Snort, sorry, Splunk. So you can use that across Splunk. You can use it across other SIMs as well. Very powerful for creating correlated events. You can pull in different log source types. And then we mentioned before a number of times the correlation. This is one of those mechanical things you can use to help to do that correlation. So if you have a behavioral rule that says we have a known bad file, then you can run a Sigma query that takes that information and then looks across other data sources for additional enrichment. You can then use this to create dashboards as well afterwards. You can create that in, for instance, in Splunk or other systems that you're using for a SIM, and you can then take the initial alert, enrich it with a Sigma query, and then create a dashboard, which then helps you to shortcut that process next time you need to look at that information. It's also going to be very, very powerful for threat hunting. So in wrap up, we just covered defense in depth strategy, the history of defense in depth, examples of defense in depth architecture, and linkage to monitoring and alerting. We also reviewed security monitoring tools technologies. We discussed where, why, and when to monitor, discussed the concept of active defense, and practical examples of tooling and technologies to consider based on a notional ransomware incident. I expect that after this, you may have some more curiosity and more interest in digging further into these topics. I certainly suggest that. This is not intended to make you an expert today, but it's intended to maybe uh, build up your appetite and make you interested in understanding some of the concepts with regard to this. Okay, Rigo, we're ready to switch over to the Q&A.
Awesome. Thank you so much, Pierre. And before we dive into the audience questions here, so just want to circle back to the results of that poll question, Pierre. We got a vast amount of answers here from the
Oh,
audience
wow.
here. So
I'm
we
seeing
have,
that. Okay.
yeah, we have SOAR, we have MFA, network
Okay.
segmentation, firewalls.
Nice.
What do you think? Yeah, what do you think
Um,
of these?
I like the fact that MFA is one of the largest ones. That's I won't say it's a requirement, but it's certainly an expectation for most environments these days that multi-factor authentication is deployed. And it does prevent the casual misuse of a password that's been exposed. And that happens too often. So having MFA listed there makes me happy. I like the fact also that network segmentation is as big as it is too. I used to actually spend time as a network segmentation engineer here with Cisco in my earlier in my career as well. So I've got a little bit of a warm spot in my heart for that. And it's an important thing to consider when you're looking at security controls to have those different network perimeter segments to be able to protect things as necessary. I see firewalls in there. I see SOAR, and SOAR is an important enrichment point for a lot of the automation we talked about. So using SOAR, which is again that automation technology to enrich alerts. If you find a bad thing, it can tell you more about it. That is a powerful capability that can be then tied into AI or other automation as well. I see logging in there, which I'm glad to see that too. Logging is fundamental to everything. Without logs, you don't have an investigation. Even if you have all the other fancy tools in the world, if the adversary has wiped out your logs, you're not going to get very far in your investigation. Great. Thanks, Rigo.
Awesome. Thank you so much, Pierre. Appreciate you talking about those. So now we're going to go ahead and move on to our live Q&A. So we're going to take some questions here from the audience. So let's see what we have here. For the first question here, Pierre, is does Wi-Fi increase the risk of network security being infiltrated, or a region where IT cybersecurity is not a priority, or make it more prone?
Okay. Not necessarily, not by itself. It depends on the deployment of Wi-Fi. Wi-Fi can be deployed in a secure way, but it also bypasses our classic physical controls. So if we think of a network being wires in a wall and you have ports in the wall you plug into, if I also have wireless, then I can have someone in my parking lot also trying to log in or whatever else. If you have your wireless network set so that it requires a strong authentication that's encrypted and that it maybe also requires multi-factor authentication, then you've done your due diligence with regard to your authentication section and you validate who's coming in. Then you also terminate that Wi-Fi connection at a place where you can then do additional inspection, and you treat it not necessarily as untrusted, but you treat it as marginally trusted maybe. And so you have to do a little bit extra analysis and monitoring toward it. I think that's a good approach. There are definitely ways of bypassing a lot of the security controls within Wi-Fi. Wi-Fi, being a relatively newer technology, has a number of vulnerabilities we've found over time, and so it's important for us to stay on top of those vulnerabilities as they're identified as well.
Awesome. Thank you so much here. For the next question is there any solution or a way to prevent unauthorized encryption of data?
Have a good backup. Um, Preventing it, there are possibly, but the best defense, the most reliable defense that I've seen in years and years of working on ransomware incidents is those environments that have a reliable offsite or non-network connected backup. Then they can go back to that and say, we're going to nuke that network. We're going to remove it. We've got this backup, which is known good, and I can recover from that. I don't need to worry about negotiating with these adversaries. I don't need to worry about paying that. I have a backup I can go back to, and I'm okay.
Perfect. Thank you so much. Another question that I see here is this is actually circling back to an earlier slide that you were presenting, Pierre, the network map slide. Did we make note of any potential risks?
Yes, a number. So the VPN system being identified there where it was, again, the layout there was intended sort of to have a conversation. So that location of the VPN server was intended to provoke identify as a risk. So there's a good example. Um, there could also be misconfigurations on firewalls that allow users to pass through without being properly re-authenticated or making sure the authorization is set, etc. There's a lot of configuration weaknesses that could be there. Um, so there are definitely some. And as always, the risk of entropy over time, the security of it will degrade without proper maintenance. That's always present.
Perfect. Thank you so much. And looking at our time here, I think we'll go ahead and squeeze in maybe one or two more questions before we wrap up for today. Next question here is if every layer of defense assumes compromise, what layer becomes the most critical to preserve trust?
Um, Depending on how far the compromise is, I would say sometimes you need to start over. We've had to give that advice to customers before when they've had an environment where the adversary completely controls an environment. Sometimes it's not possible to claw that back. Sometimes it's the right thing to do is create a new network, a new clean network, known good network, and you rebuild it and put the right controls in place there. That's it's a painful thing to say, but it's often true. And sometimes the best way of starting with this and dealing with this is by starting over.
Awesome. And our final question for today is defense in depth then really is an umbrella system rather than just an enclave. Would that be correct?
Um, there for defense in depth, I like, and we're talking about segmentation. I like the using the term an enclave to have enclave segments within an environment, like network enclaves. I'm not sure if that's exactly what they were talking about, but it definitely starts from the outside in. You want to have layered defense at the perimeter. You want to have secure challenges within the environment where you're doing authorization and authentication validation, and additional observation or enforcement points as you move within the environment. So the idea of perimeterless security, where you're not just dependent upon only that moat and that wall, you're also looking at the inside as well and how a adversary may move or a user may move within the environment to get places they should be going and where you prevent them from going places they shouldn't be going.
Perfect. Thank you so much, Pierre. So with that answer, I think we're going to go ahead and wrap up the presentation for today. Pierre, I just want to thank you again for this great session and for sharing your knowledge and expertise with our audience. I hope that everyone found great value in today's presentation and that it is helpful with your exam studies. And I also just wanted to take a moment to share a few quick items with everybody. So for this program, we have one more session coming up in November, November 20th to be exact. And for the next topic, we're going to be covering host-based analysis through the eyes of a malware researcher. We hope that you can tune in for this next live stream as well. If you haven't already, you can go ahead and register to receive email reminders, and you can easily add the session to your calendar so that way you don't forget. You can go ahead and scan that QR code on your screen to register for the CCNA Cybersecurity Prep program, or you can use a link that's provided on your Slido screen as well. And I also wanted to share a few resources with everybody. So my teammate Tanner Swift published a nice post for Cybersecurity Month that contains a list of resources to help you along with your cybersecurity journey. Some of those resources include various tutorials on Cisco U that cover multiple cybersecurity related topics. You also have some opportunities to earn free CE credits, and there's also a giveaway. And actually, there is still time to enter that cybersecurity training and certification giveaway. If you haven't signed up for it already, you have until November 14th, and you'll have a chance to win a nice learning and exam bundle. So we highly recommend that you go ahead and sign up and we wish everybody luck on that win. Go ahead and you can make your way to these resources by scanning that QR code on the screen, but the link is also provided under your Slido resources as well. And one other piece of information I wanted to share with everybody who might be thinking of taking their CCNA cybersecurity exam, or maybe another Cisco exam sometime soon. There is a Cisco exam safeguard offer that allows candidates to retake their exam at no extra cost if they fail their first attempt. So this safeguard is available for the CCNA cybersecurity, and also select professional level core exams. So it's just something to consider for added reassurance, or just as a backup plan, just in case you need it. To learn more about it, you can go ahead and scan the QR code on your screen, and you'll be taken to the page where you can read all of the details about the offer. We hope that you take an opportunity to consider it, and just to get that peace of mind for your upcoming exam attempt. Um, and then last but not least, we have also launched a survey on Slido, and we would be so grateful if you can just take a moment to complete it and let us know how you like the presentation. We always look forward to receiving your valuable feedback and comments. So go ahead and take a moment, if you would, please. We would really, really appreciate it. Thanks again to our presenter Pierre, to all of our attendees for joining us here live, and to our producer James McDonough. I hope that you all have a great rest of your day, and we'll see you next time on the Cisco Learning Network. Thank you all so much.